Today we are going to continue looking at our trig functions, and we are going to do part 2 of our trig ratios. If we read through today's objective, we see that by the end of the lesson today, we will be able to use inverse trig ratios to solve for missing angle measures in right triangles. Yesterday, we were using regular trig ratios to solve for missing side measures. So our lesson today is going to be directly related to our ratios from yesterday, but we are going to be solving for missing angles instead of missing sides. We will also be using what are called inverse trig ratios. The word inverse, if you remember from Algebra 1, inverse operations were opposite operations. So when we are talking about inverse trig ratios, we are going to be looking at opposite trig ratios. So we are going to be moving trig ratios to the other side of our equation today. Inverse trig ratios look a little bit different than regular trig ratios. So you will see under the exercise, the note 6.4 part 2 for today, that we have an inverse sine, an inverse cosine, and an inverse tangent. So we are going to be looking at some different notation today and learning how we use that with our trig functions and how we input that into the calculator. When we have completed our lesson, we have a worksheet and exit ticket. If you think back to the lesson that we did yesterday, we talked about our 3 trig ratios, our sine, our cosine, and our tangent. Each one of these ratios involves 2 sides of a right triangle. So in your right triangle, you are going to have what we call a reference angle. Now, according to where your reference angle will determine where the 3 sides of the triangle are, your opposite, your adjacent, and your hypotenuse. So let's start with your hypotenuse. The hypotenuse is the easiest to locate because the hypotenuse is always in the same position. Your hypotenuse will always be opposite your right angle. So our hypotenuse is going to be right here opposite our right angle. Now, when determining your opposite and adjacent, those sides are all determined by where your reference angle is. If you think about the definition of the word opposite, opposite means on the other side. So, if our reference angle is in the bottom right-hand corner, then our opposite side should be over here on the left-hand side. Left is opposite of right. Now, the third side in the right triangle is what we call our adjacent side. We talked back in Module 1 about the fact that the word adjacent means next to or touching. Now, the third side in the triangle, which is down at the bottom, is in fact touching our reference angle. So, we are going to call the bottom side there our adjacent side. Now, we learned the phrase SOHCAHTOA yesterday to remember the relationship between our 3 sides. So, for sine, we need or require an opposite and a hypotenuse. For cosine, we need adjacent and hypotenuse. And for tangent, we need our opposite and adjacent. These same rules will apply for our problems today. Now, on this slide, you will notice a little bit of a different notation. You will notice a small -1 as an exponent by your sine, your cosine, and your tangent. This -1 is known as inverse notation. The -1 does not do anything to the problem, but it actually uses your inverse notation to solve the problem. So we are not actually going to be finding the sine of x, cosine of x, and tangent of x. We are going to be using the inverse notation with the opposite sides. So your equations will look a little bit different today. So now we will begin our examples on finding missing angle measures using our inverse trig functions. Please pause the video and copy down examples 1 and 2. Let's start with example 1. In example 1, it asks us to find the measure of angle x to the nearest degree. Now, we will begin our problems today the same way we began our problems yesterday. The first thing that we need to identify is our reference angle. So let's go back and read our problem and see if we can identify our reference angle. So it says find the measure of angle x. Now that tells me that angle x is my angle of interest or my reference angle. So I'm going to go ahead and mark angle x on my figure. Now, our second step in the process was to label our sides according to opposite, adjacent, or hypotenuse. Now, in order to determine the sides, we need to look at the reference angle and determine the relationship between the reference angle and each one of the sides. So let's begin with the 6. Now, I notice that the 6 is on the left side of the triangle. The reference angle is on the right side of the triangle. Left and right are opposites of each other, so that would tell me that the 6 is the opposite side in my triangle. Now let's look at the 10. What I notice about the 10 is that the 10 is opposite the right angle. In any right triangle, we know that the side opposite the right angle is always our hypotenuse. So far in our triangle, we have opposite and hypotenuse. So let's go back and review our relationships. Remember back yesterday, we talked about SOHCAHTOA. Now, what this SOHCAHTOA tells us is the relationship between each trig measure and the sides that we are going to use. Now, because I have the opposite and the hypotenuse in my problem here, that is going to tell me that I am looking at my sine function here. Sine has opposite and hypotenuse, so I am interested in my sine function. So what I'm going to do is write my regular sine equation like I did yesterday. So I'm going to do sine of x is equal to opposite over hypotenuse. Now we want to fill in our equation with the information that we know from our problem. So I'm going to bring down my sine function. And remember that with the sine function is always the angle in the problem. Now, the angle is what we are trying to find in our problem, so we are going to leave our x alone. Now, let's look at the right side of our equation here. I want opposite over hypotenuse. So if I look at my triangle, my opposite side is the 6, my hypotenuse is the 10. So opposite over hypotenuse would be 6 over 10. Now, at this point, I want to get my x by itself in the equation. In order to do that, I need to get rid of my sine function here. In order to get rid of a sine function, you cannot simply divide, because multiplication is not taking place in the problem. This is where your inverse sine is going to come into play. So what we are going to do is we are going to take our sine function to the other side of the equation. Now when we move our sine function to the other side of the equation, it becomes our inverse sine. So I am going to bring my x straight down, and I'm going to move my sine to the other side of the equation as an inverse sine. So sine to the negative first. Now, the inverse sine is being taken of 6 over 10. Now, this is the stage where we are now going to turn to our calculator. We want to put this expression here in our calculator. Now, if you look at your calculator, you will notice just above the sign button on your calculator, there is a sign to the negative first, or an inverse sine function. So in order to put this expression in our calculator, we are going to find our inverse sine button on our calculator by pressing second sine. Now, you should see the expression of the inverse sine in your calculator when you press second sine. That function will open a parenthesis for you, and you are going to enter your 6 over 10 in the parentheses. Now, we enter that in the calculator simply as 6 divided by 10. You will close your parenthesis in the calculator and hit enter. When you put this function in the calculator, you should have gotten 36.86, which rounds up to 36.9. So we're going to write x is equal to 36.9, and we are talking about an angle measure, and our angles are all in degrees. Now let's continue with number 2. Number 2 says find the measure of angle x to the nearest degree. So I again know that I am looking at angle x in this problem. So I am going to put my angle marking, my arc, at the reference angle of angle x. Now you will notice that angle x is not in the same position as it was in the previous problem. So when we label our sides, we need to take that into account. So let's look at where our sides are in the triangle. I'm going to start with the 15. Now, I know that the 15 is not the hypotenuse because it is not opposite the 90-degree angle, and I notice that the 15 is touching the angle. Remember that we talked about yesterday, the definition of the word adjacent is next to or touching. So because the 15 touches the angle x, I know that this side is my adjacent. Now let's look at the 20. I notice that the 20 is opposite the right angle. The side opposite the right angle in any right triangle is always the hypotenuse. Now, let's look at the two sides that we have to determine which one of our 3 trig functions would be appropriate. Now, when I look at the top in my SOHCAHTOA, I notice that in the center, in the K part, that I see adjacent and hypotenuse. Adjacent and hypotenuse are associated with the cosine function. So I know that the cosine function is the one that applies to this particular problem. So I am going to write my basic cosine function, or cosine equation. So I have cosine of x is equal to adjacent over hypotenuse. Fill in my equation with the values from the problem. So bring down my cosine. I do not know what my angle is. That is what I'm going to try to find here. So I'm going to leave my angle as x. Now let's look at my adjacent over hypotenuse. Looking at the triangle, I see that my adjacent side is here on the left. That value is 15. My hypotenuse is on the right, and that value is 20. So adjacent over hypotenuse is going to be 15 over 20. Now at this point, I do want to get my x by itself on the left-hand side, so I need to move this cosine function to the other side of my equation. I cannot divide by a cosine function, so I need to use my inverse cosine. So I am going to take my cosine to the other side by making it an inverse. So I bring down my x. My cosine moves to the other side as an inverse cosine. And the values that I have on that side are 15 over 20. Now we are at the step where we are ready to use our calculator. So we are going to turn to our calculator and we are going to put the entire right side of the equation into our calculator. So I will do cosine inverse, which is second cosine for the inverse cosine, of 15 divided by 20. Now, when we put this value in our calculator, you should have gotten x is equal to 41.4, and that is in degrees. Now, please pause the video, and if you have any questions on examples 1 or 2, please ask now. Now we are going to continue with examples 3 and 4. I will be moving a little bit faster through examples 3 and 4, so if you need to replay or pause the video, please feel free to do so. If you also would like to try 3 and 4 on your own, you can pause the video now and check your answers when you are finished. So on example 3, I am asked to find the measure of angle T. So I know in my problem that my reference angle for number 3 is going to be angle T. So I am going to mark angle T on my triangle. Now, the two sides that I have in the triangle are 7 and 13. So I need to determine the relationship between the reference angle and the 7 and the reference angle and the 13. So let's look at the location of the 7. I notice that the 7 is on the left side of my triangle. My reference angle is on the right side of the triangle. Left versus right is an opposite relationship. Therefore, the 7 represents the opposite side of my triangle. I notice with the 13 that the 13 is opposite my right angle down here in the bottom left corner. In every right triangle, the side opposite the right angle is the hypotenuse. So, given my opposite and hypotenuse here, that is the SO part of SOHCAHTOA. So I know that my sine function applies to this particular problem. So I'm going to do sine of x equals opposite over hypotenuse. I am going to leave my x in the problem because I do not know the angle measure. That is what I'm trying to find. Then I'm going to plug in my opposite and my hypotenuse. So 7 over 13. Now, once I have written my equation, I need to get my sine function to the other side of the equation. Now, we cannot just divide by a sine function, so we are going to turn our sine function into an inverse. So I am going to bring down my x. I am going to turn my sine into an inverse sine, and the values were 7 over 13. I will now grab my calculator and put the right side of my equation here into my calculator. So I am going to press second sine and put 7 divided by 13 in the parentheses. Now, when you calculate this value, you should have ended up with x is equal to 32.6 degrees when rounded correctly. Now let's look at number 4. Number 4 says find the measure of angle T to the nearest degree. So I again see in number 4 that I am still dealing with angle T. Angle T is still down in the bottom right hand corner of my triangle, so I am going to mark angle T. Now let's look at the location of the two sides that we are given in the problem. I have the 8 down at the bottom, and I have the 10 above. Now, looking at the location of the 8 in this problem, I notice that the side that is marked 8 touches my reference angle right here. The word adjacent is the word or vocabulary term that we are looking at in this section that talks about being next to or touching. So I know that my 8 has to be the adjacent side because it actually touches the reference angle. Now, the second thing that I notice is that the 10 is opposite the right angle here. Opposite the right angle is always the hypotenuse. Now, thinking about my SOHCAHTOA, I'm thinking about the ka part. I have adjacent and hypotenuse in my problem, and my cosine involves adjacent and hypotenuse. So I'm going to write my basic cosine function. So cosine of x is equal to adjacent over hypotenuse. I'm going to plug the values in from my problem. Bring down cosine. I do not know what my x is because that is my missing angle. And then I'm going to fill in my adjacent, which is 8, and my hypotenuse, which is 10. Once I have completely filled in the equation, I notice that my cosine needs to be moved to the opposite side of the equation. When I move my cosine to the opposite side of the equation, it will become an inverse. So I will bring down my x. My cosine will become an inverse cosine. And my values are 8 over 10. I will now use my calculator to put the right side of my equation in and solve for x. So I will be doing second cosine and in parentheses 8 divided by 10. When I put that in my calculator, I get a final answer of x is equal to 36.9 when rounded correctly, and that is in degrees. We will now look at our final two examples. You will notice that the figures in these two problems look a little different. Instead of identifying the reference angle in the actual sentence, the reference angle is located in the triangle. So I have identified the reference angle using an X in the triangle. Now my steps are exactly the same as they were. I am going to start by identifying my reference angle, which in this case is my X. And I am going to label my sides according to that reference angle. Now my sides are 24 and 29. I notice that the 24 is on the right side of the triangle and my reference angle was on the left. Left versus right is an opposite relationship. So I know that my 24 represents the opposite side in my triangle. Now looking at my 29, I notice that the 29 is opposite the right angle. So I do have a hypotenuse here. So we will notice once again that we do have a sine function here of opposite over hypotenuse. So I will write my equation. Sine of x is equal to opposite over hypotenuse. Fill in my values. My angle is in fact x in this problem, so I will leave it x. My opposite was 24. Hypotenuse 29. My sine function needs to move over to the right side of the equation. So my x will be brought down alone, and my sine has moved to the right side as an inverse sine. I have now reached the point where I need to use my calculator. So I am going to enter the entire right side of my problem into my calculator. I am going to press second sign and then 24 over 29. When I put these values into the calculator, I reach an answer of x is equal to 55.9 degrees when rounded correctly. Now let's look at our final example, number 6. Again, our reference angle is located in the triangle. So I am ready to begin labeling my sides. I am looking at the 11 and the 17. Now I notice that my 11 on the right hand side here is actually touching the reference angle. I also notice that the 11 is not the hypotenuse because it is not opposite the right angle. So therefore, if my 11 is touching the reference angle, it must be the adjacent side of the triangle. Next, I'm looking at my 17. My 17 is on the top of the triangle. My reference angle is on the bottom. Top and bottom are opposites of each other. Therefore, the 17 represents the opposite side of my triangle. Now, given that I have the opposite and adjacent side in my triangle, I am considering my tangent function, or the TOA part of SOHCAHTOA. So I will set up my tangent equation. So I have tangent of x is equal to opposite over adjacent. Fill in the values. I have tangent of x is going to remain because I do not know my angle. It is marked x. My opposite is 17. My adjacent is 11. Now, one of the things that you may notice about the tangent function, all of our equations that we've had so far have had proper fractions, meaning that the numerator is always smaller than the denominator. That will happen on sine and cosine always. The only time you can have an improper fraction with a larger number at the top is if you have the tangent function. You will know if you have written your fraction backwards on the sine and cosine function because you will get an error in your calculator when you go to solve the problem. So at this point, I have my tangent that needs to move over to the right-hand side. I am going to bring down my x. My tangent will turn into an inverse, and I have 17 over 11. Now, I need to calculate this value in the calculator, so I am going to do inverse tangent, or second tangent, of 17 divided by 11. Now, when I calculate this in my calculator, I ended up with an answer of x is equal to 57.1 degrees when I rounded my answer.